In this video, we'll talk about relational operators, but first let's talk about decision making in programming. In programming, sometimes we need to execute different parts of the code depending on certain conditions, and to do that, the program we are using, like MATLAB, needs to make decisions, and decision making in programming is done using conditional statements. These statements are done or contain the relational operators, like what we will discuss in this video, and or logical operators that we will talk about in a different video there. And the results of these statements, they evaluate as either true or false. If they evaluate as true, then it's 1. If they evaluate as false, then it is 0. So if the condition is true, then the program will run certain code. If the condition is false, the program will run different code. Remember that in MATLAB, true is always means 1 and false means 0. The first part of operators that are used in decision making are called relational operators, and mainly they compare numbers or variables together, and also we could also use arrays. And this is what you can see is the list of relational operators that we could use: less than or equal, greater than or equal to, and not equal to. And pay special attention to equal to should be 2 equal signs, not 1. And the same thing for not equal, it's the tilde followed by the equal sign. The comparison statements that we will do using these symbols should evaluate as either true or false. Again, if it is true means 1, if it is false means 0. That will help us make a decision later. Okay, let's look into some examples here. So the first one, if we put a comparison statement, 5 is greater than 8, so that's not a true statement. So this is false, which is also means 0. If we look at the second example here, 5 is smaller than 10, so this is a true comparison statement, which means 1. So we could write our code in a way that if the comparison statement evaluates true for something else to be done, if the comparison statement evaluates false for something else to be done. So that help us make a decision. Let's look at these examples in MATLAB. So if we first one, if we write 5 larger than 8, so let's see how that's execute. So you can see 5 is not larger than 8, so it evaluates as a 0, which is kind of logical 0 here. So let's look at the second example. 5 is smaller than 8, so this is a true statement, so this should evaluate as 0 when we execute the program. And you can see it evaluates as true, which means 1. We could also do comparison statements using variables. So let's say if we say x equal 5, y equals 6, and let's say if we say x equal to y, so that's, we know 5 does not equal 6, so that should evaluate as since it's false, we should get a 0 answer, logical 0. And you can see here we get logical 0 for that. We could also use relational operators to compare arrays, like in this case array A to array B, but as you can see they should be in the same length. Like in this case we have each of them has four items, and the comparison will be the first item compared to the second item, I mean the first to the first, second to the second, third to the third, and fourth to the fourth, and the result will be the same length arrays and with the results of the comparison. So let's see for this one, kind of we say A is larger or equal than B. If we look at the first one, 1 is not larger than 2, so that should be a 0. If you look at the second one, 5 is larger than or equal to 4, so that should be 1. If you look at the third one, 3 is not larger than 7, so we should get a 0 for that. And then if you look at the last one, 9 is larger than 8, so we should get a 1 for it. So let's run it and see what we get here. So you can see here we got 0, 1, 0, 1, which is what we expected there. So as a logical comparison between the two arrays. We could also compare numbers to arrays or variable to array. Like in this case we could compare the 5, which is the number to the array A, but in this case the number like the 5 will be compared with each of the elements in array A, and we get another array with either zeros or 1. So let's see here, A does not equal to C. So if you look, the first one, 5 does not equal 1, so this should evaluate to 1. 5 equal 1, so that's 0. So let's run it and see what we get here. So you can see the only one that's not, because remember this is not, so 5 is not, 5 is, this is a false statement, this is why we got a 0 here for the second one. For the other elements, 5 does not equal to 1, which is true, so that's 1, and 5 does not equal to 3, which is another 1. 5 does not equal to 9, and this is a 1. So you can see we get the result will be an array with the same number of elements. Since only the comparison that evaluates true give 1, we could find how many comparisons evaluated true, so mainly just by using the sum with the statement. So like if we use sum with how many comparisons where A does not equal to C. So that's if we run it, so that's mainly 1, 0, 1, 1, so it will just count how many ones, because the zeros will not affect our results. So that's kind of quick way of finding how many elements in that did not evaluate, or that evaluated true. So you need to be familiar with the relational operators, and make sure don't leave a space between the smaller than and equal, and whenever you need to use equal, you need to use two equal signs, not one. The one is used to assign value, like if we say x equal 5, which is mainly saying that we assigned 5 to value 5 to the x variable. And so that's, again, don't remember to use two equal signs and don't leave space here, and always the results is either true or false, and if it is true, evaluates as 1. If it is false, it evaluates as